Packet switching is breaking large data that you want to transmit into smaller packets and sending it over the network, and each packet can travel through different routes on the network. So, let us say computer A has a large file that it wants to send to computer B. So, there is a large file that computer A wants to send to computer B. This large file is going to be broken up into parts, right? And so, we are going to create small data packets where each packet can only carry 64 kilobytes of data maximum, okay? No more than 64. A packet can carry less than 64 kilobytes of data, but not more than 64 kilobytes of data. So, here we can see that the file we had has been broken down into 5 packets, right? Brown, gray, green, blue, red, just these different shades to indicate, that these are different packets from that one big file that we had. Maybe it's a web page that computer A, wants to send to computer B, because computer A probably is a web server, right? We can think in those terms. Right. So, it is a web server, computer B requested a web page. So, computer A is now sending that web page back to computer B, but because it was a large web page, it has been broken down into packets, and now these packets are going to be sent. Okay, if we take a look at this diagram, we can clearly see that each packet is kind of traveling through a different route. For example, the packet in red is taking this route, right? That is the route it takes to computer B. The packet in green we can see is taking this route, right? It is just going this way to computer B. Let us just do one more. We can see that the blue packet took this route to reach computer B. So, each packet can take a different route. 2 packets can take the same route, but basically for each packet the routers in the network make decisions, right. So, it is possible that one packet from router 2, which is the green packet, may be sent this way, and the other packet, which was the red packet, may be sent this way. It all depends on the amount of traffic. See, router 2 is going to see whether router 1 is busy. If router 1 is busy, it is going to send the traffic through this route. If router 5 is busy, then router 2 is going to send the traffic through this route. So, basically the intention of the router is to send the packet through the shortest path, and by shortest path we mean in terms of time, right. So, maybe in this case sending a packet this way might not be the shortest path, because these routers are busy, right, they are busy. So, maybe sending data through a route which might look a bit longer is probably faster, right. So, each router makes a decision, and the focus is that it has to send data packet through the shortest route. Here is a quick look at what kind of fields are attached to a packet, right. When a packet is created, you can carry no more than 64 kilobytes of data, right, and this is called the payload. The actual data that is being carried inside the packet is called the payload, and the payload cannot be more than 64 kilobytes. It can be less than 64 kilobytes, but if you have a larger file, you are going to create small packets such that the payload cannot exceed more than 64 kilobytes. Okay. So, now there are other important fields that are connected, right, that are attached to this packet, right. The sender's IP address, the destination's IP address. In this case, for the example that we were considering, computer A's IP address, right, IP address of computer A, IP address of computer B, right, because this is the destination in this case. And then the sequence number of packets, and remember in that diagram that we were just discussing, we had 5 packets. So, so the packet number comes here, right, whether it is packet number 3, 4, 5, 1, 2, right. Let us say this was packet number 2, right, and the size of the packet, whether it's carrying 64 kilobytes or more or less, right? uh, and then some way of identifying that we've reached the end of the packet, right? So basically, a router is going to receive packet one after the other, right? A router is going to receive packets one after the other, and when the router receives those packets, it should be able to tell when the packet has ended, right? So that it knows that now the next packet is starting, and now the next packet is starting. So there must be some way of identifying uh, whether it has received a packet completely. So something is being done here, right? And then here some sort of error checking method to make sure that the packet has arrived error free, and this is typically CRC in our book. And in CRC, basically we count the number of ones, right, in the payload, how many ones there were, because the data is going to be in the form of ones and zeros, right? Let's say the data packet that was going had 12 ones, right? Or maybe 32 ones or 40 ones, right? So, so those ones are counted and they kind of saved. A hexadecimal value is saved here. So if you wanted to save 40 as hexadecimal, that would be what? If I use place values, right? 116. So I need to make 40, 2 16s are 32 plus 8. So this is the hexadecimal value, right? So something like 28 would be stored here to indicate that the packet, the payload, had how many ones inside of it? 28 ones. So the receiver is going to count whether the received packet has 28 in hexadecimal, by the way. Actually it is 40 ones, right, in the denary number system. So it's going to count whether the exact number of ones are there or not. So we use CRC for that purpose. The sequence number we know is important because packets may arrive out of order, right? When you're sending packets, packets may arrive out of order. You can see the order here is different, right? Is brown, gray, green, blue, red, but here it's different: red, gray, brown, green, blue, indicating that the packets have arrived in a different order. Red was received first and blue was received the last, whereas here we can see that red was sent first and brown was the last one to be sent, right? So packets may arrive out of order, and this is where the sequence number is going to come in, right? Whether this was sequence number 3, sequence number 1, I'm just randomly numbering those. But if we were to number these here, 1, 2, 3, 4, 5, then brown would be 5, right? And gray would be 4, and red would be 1, right? So based on these sequence numbers, the computer B can reassemble the web page. Remember we said that this was a web page being transferred, right? So we were just trying to build a scenario, right? So the web page can be reassembled in the right order based on these sequence numbers. So now we know what the sequence numbers are there for. Now we know what what CRC was being used for. We know why we included some way to indicate the end of the packet. Besides that, there was the sender's IP address and the destination's IP address, right? So the routers are going to use the destination IP address. They're going to use the destination IP address to decide whether to in which direction to forward the packet that is received. So this router 2 studied the destination IP address in the green packet and then decided that it was going to forward this packet in this direction. Okay, it could have sent it here, but maybe router 5 was busy, so it did not send it in that direction, right? And it forwarded it towards router 1. Okay, so the router 2 makes a decision on makes a routing decision, right, based on the destination IP address. Okay, now just a few quick things. Packet switching is more secure. We can see why it is more secure, because even if it would be difficult for the hacker to uh, determine the route which is going to be taken. There is no single route. Each packet travels through a different route. So if the hacker was to tap this router, if the hacker was to tap this router, right, then he could only get access to the green packet, right? The other information, all the other packets were traveling through different routes. So this way, in packet switching, the hacker will not be able to get hold of the complete data, the complete, for example, web page that we were transmitting. It is only going to get part of it. So packet switching is secure that way. Inherently it is secure, that's something that is by nature, because all packets travel through different routes, it becomes secure. Okay. Now there's just one final thing that we want to discuss is that if we were transmitting a video in this direction, right, if we were transmitting I shouldn't say video, I should say um, if we were live streaming, right, and by live streaming it could be a WhatsApp video call, or an WhatsApp audio call, right, or some cricket match that is taking place right now that you're watching on the internet, right? So live streaming, is packet switching suitable for that? Well, it is not, it is going to create some problems, because what happens is that packets are received out of order, right? Packets are received out of order, and you have to wait for the packets to reassemble them, right? So you have to wait for the packet to reassemble the data in the right order. But what if some packet is taking too much time? Then this is going to cause what? This is going to cause delay, right? And you cannot afford delay in a live streaming application, right? Imagine watching a cricket match and all of a sudden the video is stalled, right? Or it's taking too long, and the video is getting streamed with a lot of delay. That would not be good for user experience. So when packets are received out of order, they need to be assembled, and that can cause delay. Sometimes packets can be lost. Packets can be lost. So live streaming, some packets can be lost because router 8, for example, was busy, and it dropped some of the packets because it was too busy, right? So those packets are not able to go through. They need to be retransmitted, right? So that is going to create delay. So sometimes what happens is, when you're watching these live streaming events, you see that the video sometimes, the entire frame is not visible, right? Parts of the video are not visible because some packets didn't come through, the frame was not complete, right? The video stalls at times, right? Because it starts, stops, starts, stops, right? Um, so these are the kind of problems that you face. If and in case of audio, the audio that you're receiving through live streaming may be choppy. The audio may be choppy. It breaks up. You hear something, the voice breaks, and then you hear something else, right? So the conversation in between is lost sometimes. So those are the kinds of things that you can experience. Okay, one final thing that I just remembered, that should also be considered in this case is that, sometimes router, for example, for this blue packet, let's assume, router 6 decides to send this packet, blue packet, to router 8. Router 8 sees that router 7 is busy, router 9 is busy. So what does router 8 do? It forwards this packet to router 5, thinking that router 5 will now forward it through router 3 onto its destination. But router 5 sees that router 3 is also busy. So what does router 5 do? It decides to send this packet back to router 2. Okay, and router 2 is going to do what? Router 2 is going to take a look, and it sees that router 1 is busy, so it's going to forward it to router 6, right? And router 6 once again, is stuck, because what's it going to do? It's going to send it to router 8. Router 8 once again finds that this is busy, this is busy. It's going to send it back to router 5. So what happens is that this blue packet keeps circulating in a loop between these routers, right? And because of that, you know, if too many packets, get stuck in this loop, right, they keep circulating because because all the other routers are busy, so they are not able to go through finally towards their destination. Rather than they're stuck in a loop between these routers. uh, then this will eventually slow down the network a lot if there are too many packets like that. How is that prevented? Well, when these packets are created, there is something called a hop number. We've not seen that. We've not seen that in. We've not seen that here, right? We've not seen the hop number here, but you should know that there is a hop number field also. Okay, so I'm just going to add it here, right? There is a hop number field also. Okay, and the hop number, for example, could be 7, let's say, or could be 6. All right, which basically means what? Which basically means, and I'm just going to go to this cleaner diagram here. Okay, which means what? For example, we had these packets, right? And this packet, for example, had a hop count of 6. When this packet goes from router 1A to router 2, the router 2 decreases its hop count by 1. So hop count is updated to 5. From router 2 it goes to router 5. Router 5 also decreases the hop count to 4. From router 5 it goes to router 8. Router 8 receives the packet, reduces the hop count to 3, takes a look at the destination IP address, decides to send it to router 7. Router 7 is going to receive the packet, reduce the hop count by 1, and router 7 now takes a look at the destination IP address and sees that router 4 is busy, router 10 is busy, router 9 is busy. What is it going to do? It's going to send it to router 3, and router 3 is going to receive this packet, right? And router 3 will reduce the hop count by 1, take a look at the destination IP address, and then decide which way to forward this particular packet. So maybe router 3 is going to forward it in this direction to router 4. Router 4 receives the packet, and it's going to reduce the hop number, and guess what? The hop number has reduced to 0. Now router 4 sees that the hop number is reduced to 0, which basically means what? It's going to drop this packet. It is going to drop this packet because the packet's life was as long as the hop number had not reached 0. So unfortunately this packet is not able to go through to computer B, and this only happened because the network was busy, or and maybe if the packet gets stuck in a loop, the hop number is going to get reduced, eventually it becomes 0. So that is how we avoid a packet from endlessly circulating. Okay, so hopefully all the concepts related to packet switching are clear now.